Now we apply technology acceptance theories to new technologies such as autonomous vehicles, smart homes, and chatbots.
We first defined our concept: smart homes, autonomous vehicles, and chatbots. A smart home is an intelligent residence equipped with a communications network, linking sensors, AI, the IoT, household electrical appliances that can remotely monitor, accessed, or controlled, and which provides services that responds to the needs of its inhabitants. So this is a definition that you have always to give in your literature review. The main goal is to increase consumers' quality of life, safety, health, reduction in or automation of household labor, and to increase energy efficiency. So there you see directly the link to well-being. In these studies, we introduced the concept of well-being, and we show the importance of and the relevance of the topic. So the global smart home market is expected to grow very importantly from almost 120 to 120 billions of dollars in the US, but also in the European market. It is supposed to grow from 20 to 44 million until 2024. So smart homes are now the reality. Given the energy transition needed to reduce emissions, it is essential to optimize and control energy consumption via smart homes and smart cities. In Bangkok, there is one quarter which is at the point to be completely transformed into a smart city. So Bangkok wants to be in 10 years one of the major players in smart cities.
And you can see here that worldwide Singapore is the most advanced smart city. Then you can see that northern countries from Scandinavia, Helsinki, Copenhagen are quite well placed in smart cities, and Zurich in Switzerland, but you can also see that Bangkok won a lot of places in the worldwide ranking of smart cities. And the quarter in Bangkok is called One Bangkok, and it aims at changing the way people work, live, and play. One Bangkok integrates smart technologies into all aspects of the quarter, from smart parking, traffic management to centralized security and safety. Smart city innovations will enhance the experience for all visitors and residents. The centralized infrastructure system also adds efficiency with district cooling and energy management systems designed to international standards for sustainable long-term business operations and future growth. Through removing equipment and plant from individual buildings, One Bangkok can add green areas and public space throughout. This common infrastructure is also future-proof with pioneering smart city and business solutions that enhance the experiences of all users. In the apartments, in the smart flats, also smart technologies are integrated to smart beds, smart air conditioning, smart heating systems, smart kitchens. So the whole equipment will be connected to the IoT to create intelligent smart flats.
The topic is really relevant, and that's important, not only from the marketing point of view, but also from the society point of view. So smart cities, smart homes are actually a major lever to improve environmental concerns. So the key drivers are naturally the technologies, more and more internet users, which is the case, the 5G, which is developing, the development of AI, artificial intelligence, IoT, and major changes also in the legal factors in the energy market. And it is not an hazard that global companies like Google, Amazon, and Samsung have entered this enormous market, providing innovative services and products and growing demand. So there's clearly a demand for hardware, smart homes, but also for software, that is the applications that are related to the smart homes. The most important market until now is how to control and connect devices to the IoT. But you see also energy management, security, more security, comfort and lighting to optimize the air consumption, to have optimal temperatures, not to consume too much energy, but also dryness or wetness, to have better comfort in the flat. And home entertainment and smart appliances, which are connected cooks, connected kitchen, connected bed. All these are reality in the smart home to improve consumers' well-being. Even if these technologies are increasingly present and important, only 23% of Europeans or US consumers really have intention to use them. because they do not want to partially or fully delegate decision-making to AI or other machines. Their concerns include principally loss of control, loss of freedom, privacy issues, hacking, uncertainty factors, distrust, and fear that the technology can harm the health. Also that the flat goes out of control, or that the autonomous car goes out of control. This is over-mediated by the accidents that happened recently. But this offers interesting research opportunities because we probably expect much more safety from an autonomous flat, a smart flat, or autonomous car compared to a human, which we know which is not perfect compared to intelligent technology. So therefore, the contributions are to understand how and why users accept AI-based smart homes. This is an important issue. And above all, there's still enormous calls to work on AI and smart environments in order to understand how consumers perceive these technologies. And that, therefore, the contribution about smart homes is that as most of the research is done in engineering and consumer science rather than social and management science, there is a contribution to do. By shedding light on consumers' positive or negative perceptions of AI and IoT-based smart homes, in order to focus on the impact of AI and smart homes on users' well and bad-being, which are crucial variables, by enhancing the UTL2 technology acceptance theories with few investigated concepts such as privacy concerns, well-being, bad-being, technology fear, and so on. As there's scant research about technology resistance, we also contribute to this literature to show which are the resistance factors, which are also important then from the managerial point of view to avoid, to increase technology acceptance for these technologies. And we did a cross-cultural investigation in different countries being completely different in terms of culture. Two Western countries, France and Germany, and one Eastern country, China, which will vary naturally in culture, but also risk perceptions of uncertainty avoidance, and perceptions of privacy and technology. In order to see if our results hold in different contexts, we replicated the study in different technology contexts. Another study we did it for autonomous vehicles.
Autonomous vehicles are intelligent vehicles equipped with communication networks, sensors, IoT, artificial intelligence, devices that can be remotely monitored, accessed and controlled, and which provide services that respond to the driver's needs, which automates driving systems. These smart devices sense the surroundings and engage in real-time data collection, interactions and feedback analysis via AI to propose suitable solutions for driver comfort and security. The main goal is, like for smart homes, to increase consumers' road safety and reduce accidents, because 95% of accidents are caused by human error, according to the study of the Human Parliament. So autonomous vehicles should increase quality of life, safety, automation of driver labor, and should increase energy efficiency. So to give you some information about the market evolution of autonomous vehicles, according to the European Road Transport Research Advisory Council, AI-powered AVs will be available on the European market from 2020. There are different levels which we'll see in some instance. By 2023, worldwide sales of AVs driving without human supervision will reach almost 1 million of units. AI-based AVs represent a potential market of 55 million vehicles sold within the next 20 years. The most part will be sold in Asia, because Asian countries will have the first place in terms of AV sales by 2040. And the technologies used are more and more accessible with LiDAR, sensor fusion, artificial intelligence, 5G, and the regulations are becoming more and more flexible. So there are different levels of automation. What exactly are these levels? Level 0 is no driving automation. So most vehicles on the road today are level 0. They are manual controlled. Level 1 have a driver assistance. This is the lowest level of automation. the vehicle features a single automated system for driver assistance, such as steering or accelerating cruise control, which is adaptive, and this needs an important amount of human driver intervention, and the driver monitors all aspects, including steering and braking. Level 2 is what is allowed today on the roads. This means that advanced driver assistance systems control both steering and accelerating or decelerating. Here the automation falls short of self-driving because a human sits in the driver's seat and can take control of the car at any time. Tesla Autopilot or Cadillac Super Cruise systems both qualify as level 2, or Mercedes or Audi have also level 2 cars. The level 3 is conditional driving automation. This is a jump from level 2 and 3 is substantial. In level 3 vehicles have an environmental detection capabilities that can make informed decisions for themselves, such as accelerating past a slowly moving vehicle, but they still require human override. Almost 2 years ago, Audi and Volkswagen announced that next generation of the A8 would be the world's first production level 3 vehicle. And they delivered in 2019 the A8L, which was one of the first level 3 cars. In this case, the car is taking over the control, but is unable to execute the tasks. So then the next level is level 4, which is high driving automation. So the difference between 3 and 4 is that level 4 cars can intervene if things go wrong. For example, if there's a system failure. In this sense, these cars do not require human interaction in most circumstances. However, a human can still have the option to manual override. Level 4 vehicles can operate in self-driving mode, but until legislation and infrastructure involves, they can only do so within a limited area. Usually your urban environment where top speeds reach an average of only 30 miles per hour. This is known also as geofencing. So today, level 4 vehicles exist only in ride-sharing examples. For example, Navia, which is a French company, already building and selling level 4 shuttles and cabs, which reach a top speed of 55 miles per hour. Or Alphabet has Waymo with level 4 self-driving taxi service, which it's operated in Phoenix, Arizona. And level 5, the highest level of driving automation. In this level, vehicles do not require human attention. The dynamic driving car task is eliminated. Level 5 cars won't even have steering wheels or acceleration braking pedals. They will be free from geofencing, able to go anywhere and do anything that an experienced human driver can do. They are fully autonomous, based on artificial intelligence, and are undergoing testing in several pockets of the world, but none are yet available to the general public.
This is what kind of statements you have to give in your introduction, your research, any research article, master thesis. So to position your research. So we have seen smart homes and autonomous cars are highly relevant from the practitioner point of view, but also from the research point of view. Because again, like for the smart home, we have the same arguments. Consumers are reluctant to give over control of technologies to AI or to robot. As if you're able to trust or to give control to a smart watch in order to observe if we have done enough steps in our life today, or if you have done enough sports, or if you have not eaten too much calories. So these are actually low involving tasks. We are highly reluctant to give over the control to technologies which concern our safety. That's why, again, very important to understand these main barriers, which are, again, like for the smart home, privacy concerns, technology fear, the confusion of autonomous cars in unexpected situations, loss of control, because the level 5 cars won't even have anymore a steer wheel. So if we want to take the control, it becomes difficult. That is why it is important to understand to which extent customers are ready and how and why users accept or reject AI-based AVs. The contribution want to understand better the factors that influence positively and negatively the acceptance of autonomous vehicles. We contribute to the technology acceptance theories by integrating new variables, and as you can see, we have also introduced hedonism, but also effort expectancy, social recognition, well-being, and technology trust in order to understand also the consumer resistance. And final study about technology acceptance was about chatbots. What is a chatbot? It's a service robot that are conversational agents that interact with users in a strictly limited domain or on a certain topic with natural language synthesis, generally deployed on the internet for the purpose of seeking information and task-oriented dialogues for a broad range of applications.
Today, chatbots are generally deployed on the internet for the purpose of seeking information, site guidance, and frequently asked questions. But in the future, chatbots will do high value-added activities and applications, such as being a beauty agent or even mHealth agents supporting doctors. In this regard, chatbots may differ in the level of intelligence. 4 different types of chatbots and intelligences exist that depend on the nature of service: mechanical, analytical, intuitive, empathetic. Mechanical intelligence or chatbots is the most basic level and concerns the ability to automatically perform repetitive tasks that do not require advanced training. In this case, a chatbot is rule-based and it does not understand the external environment. Analytic intelligence refers to the ability to process information, to problem solving and learn from it. Machine learning and data analytics techniques allow the technology to learn from data and find insights without being programmed, allowing mass personalization based on big data. Mechanical and analytical intelligences are still considered as weak AI because they simulate intelligence but do not have intuition. But they are used to analyze big data and to give recommendations with recommender systems. At the highest level of complexity, there are intuitive intelligence, which refers to the ability of the AI chatbot to think creatively and adjust effectively to novel situations. And finally, empathetic intelligence, which is the ability to recognize and understand other people's emotions, to affect them and to respond appropriately. These 2 intelligences represent the most advanced generations of AI and chatbots, but they are still far from reality. In this regard, chatbots can be distinguished from humans in that service employees have their own limited capabilities, perceptions, and weaknesses, heterogeneity across individuals. Human employees need to have a deep understanding of the customers and service processes to deliver heterogeneous, individualized services, and to achieve this, learning is needed. Furthermore, connecting employees to customer relationship management systems requires time and efforts. Service employees represent high costs through training, but then can be a source of competitive advantage. Differentiation in service can be based on better hiring, selection, training, motivation, and organization of service employees. In contrast, chatbots acquire knowledge quickly and system-wide through CRM systems as well as AI to determine optimal solutions. Furthermore, chatbots are free from human error and fatigue, do not show heterogeneity, and automatically providing homogeneous services in a highly reliable manner. Furthermore, they do not feel and express real emotions. So they can be perfectly used in the service quality improvement process to improve service quality with self-qual. In fact, the majority of chatbots are designed at the mechanical and analytical level today. On the one hand, they offer the advantage of being cost and time effective, always available and extremely consistent. But on the other hand, they may fail to satisfy consumers and have a low potential of competitive advantage. In fact, the pre-programmed scripts may pose a risk of not properly responding to the user's requests, leading to customer frustration and dissatisfaction. For this reason, it is important to consider the level of efficiency and competences of a chatbot to meet customers' expectations. Information provision, processing, bookings, and payments are considered the most appropriate areas of service robots. But in the future, chatbots will be intuitive and empathetic. Possible applications are beauty agents or even mHealth agents supporting doctors in hospitals. This is commonly called mHealth.
Virtual doctors or virtual chatbots taking over the role of a doctor. You get advice from the chatbot about your treatment or about your disease. This is also called mobile health market. Is a highly dynamic market, which will also double in the next 10 years. Our projects, I think all major hospitals in US, Europe, are working on this, what is called e-health or mobile health. Even until 2020, 85% of all customer interactions and customer service will be handled without a human agent. And as of 2017, over 100,000 chatbots have been created, so 3 years ago. So I think it should be at least 1 million of chatbots working today. And almost all organizations plan to outsource and to automatize customer dialogue to chatbots. So you can see it is like smart homes and like autonomous cars, a highly important evolving market. And again, we have the same problem. So users are still reluctant. Above all, if you look to the mobile health sector, they're skeptical about the quality of the service production. Considering that AI is rapidly reshaping customer service, there is thus the need to comprehend which is the most effective and beneficial way to implement these technologies in order to guarantee higher perceived service quality and a positive customer experience, because chatbots aim at enhancing customer experience. So it's important to understand the perception of this new form of technology-mediated communications. And our research for the chatbot study, which is published in Journal of Service and Research Management, to understand the perception towards AI-based chatbot service agents. Investigations in marketing are missing about service frontline experiences with highly automated social presence, thus chatbot without human social presence, like the case of chatbots or service robots. So there's few research how humans actually react towards chatbots. The investigation about the perception of service quality and acceptance after a real experience with an existing chatbot is another contribution. So we worked with a real chatbot and had a real experience, field experience with a real chatbot. This is another contribution of our research. We integrated and enhanced and combined two theories. First of all, the theory about service quality, ServQual, and combined it with the technology acceptance theory. So we have two established theories which are combined in order to test them in the new emerging context of AI-based service agents and chatbots. And we studied the relationship between usability also, so ergonomics, ease of use, but also aesthetics, and its effects on intention to reuse the chatbot. And thus we created a link between different domains of research, IS literature, marketing, service literature, user experience literature, opening further research in related fields. If you combine theories or different fields, for example, IT and marketing are strongly related. So it makes absolutely sense to combine different literature streams to have an overall picture. This is actually the case of the technology acceptance theory. That is why it's also important not to look only in our field, but also in other fields to find related theories. So I will show you now our different models. So we have seen 3 technologies, 3 projects I'm actually working on. Study about chatbots already published. The others are actually submitted in different journals. We use established theory, the UT and UT, with performance expectancy, which is defined as a perception that the use of the technology will enhance the user performance. Effort expectancy, which is the perception that the use of the technology is simple and effortless. In the TAM model, this corresponds to perceived usefulness and perceived ease of use, which both should influence behavior acceptance and intention to use. And we introduced different variables which appeared relevant in our former studies about smart connect objects and IoT, which is also relevant in the literature. That is well-being, which we define as the personal state of mind linked to different factors: psychological health, social, economical, pleasure, harmony, happiness, and medical conditions. And we naturally expect that the higher the well-being given by the technology, the higher should be the intention to adopt. This is the same for social value.
Social value is the degree to which the use of the technology will enhance the user's social status within her or his social group.
Social value should positively influence intention to adopt, because they give us value within the group, and the more we have the value in the group, the higher our perceived benefits or performance expectancy, and there should be thus a positive link on intention to use. Technology trust, which is the personally psychological state of mind that the technology does not bring us vulnerability, and that this technology won't betray us or won't fail us. And privacy concerns, which are beliefs about the data flow collection done by the firm and strongly related to trust. And so the higher the trust, the higher the intention to use, and the higher the privacy concerns, the lower the trust, which would subsequently decrease the intention to use the technology. And we introduce a new concept, technology fear, which refers to the user's perception of the limited ability to manage, control, and perform securely a technology. It refers to the perceived risk of the technology itself and how it might cause intimidation, errors, accident that could harm the user's health. So the higher the technology fear, the lower the trust, and the lower the adoption probability. And technology security refers to the perceived safety of the technology itself and how it reduces human errors and accidents that can harm users' health. For all these three studies, we used established scales. These are also the scales we have used for the other technology acceptance studies. And so the performance and effort expectancy was measured with the scales coming from Venkatesh and colleagues about the UTA-UT model. The privacy concerns were measured with Hong and Tong, which we also used in the former studies, which is the scale that is used generally for privacy concerns. We measured perceived hedonism by a also well-established scale coming from Sweeney, published in Journal of Retailing. It's also established scale that works well to measure perceived hedonism. Technology fear was a little bit more difficult. It's a scale that comes actually from a C journal. And this is normally not recommended. This is a good example to show you if you cannot find established or well-ranked scales coming from top journals, sometimes you have to use scales which are not so well. And it came actually from an engineering journal, these scales about technology fear and security, but which shows actually that there's a gap to close in marketing or IT or management literature, because these concepts, technology fear and security, are not really well explored in the literature. So we have different studies. The scales all worked well according to the different reliability and validity criterions. And so Cronbach alpha is higher than 0.7 for all the scales. The Euroscore rule is higher than 0.7, so which also required to have urgent and discriminant validity. And the convergent validity rules are close to 1, which is also an agreed measure in the scales work well. We have different samples. So for the smart home, surveyed 100 persons or 102 persons in France, 88 in Germany, 111 in China. 44% are women, 56 men. The average age is 37. We primed the respondents with a video before answering the survey. So they looked at the video with a future smart home in order to show them what this smart home can do. We did the same for an autonomous vehicle where we had 207 respondents in France. Almost half of them are men and women. The average age is quite younger because it was a student sample. And again, we showed a video about a level 5 car, so a fully autonomous car before the survey. And the study about the chatbots was also done in France with Flybot, which is a real existing chatbot where we asked the respondents to search a flight before answering to our survey, so a flight from Toulouse to New York. And then we asked them how it worked. And our sample, again, it was a student sample, more highly woman-oriented, 73% women, The average age is quite young. It's also the main limit of these two studies. Okay, let's have a look on our conceptual model. So you can see here this model for smart homes, supposed in the U2T. Effort expectancy impacts positively performance expectancy. Performance expectancy should positively impact well-being, but negatively impact bad-being. And both are mediating variables on behavioral intention. So well-being should increase behavioral intention to use, whereas bad-being should decrease behavioral intention to use. And we have these technology security-orientated variables such as privacy concerns, which should negatively impact trust, technology security positively impact trust, and perceived technology fear should also negatively impact trust, but trust in turn should positively impact well-being, negatively, so decrease bad-being, and positively impact behavioral intention of use. Study we had also a concept coming from cultural management, dimensions of Hofstede. Hofstede's cultural dimensions theory is a framework for cross-cultural communication and marketing developed by Gerd Hofstede. It shows the effects of a society's culture and the values of its members and how these values relate to behavior. The analysis of the cultural framework of Hofstede identified different dimensions which can distinguish different cultures: power distance, individualism, masculinity, uncertainty avoidance, long-term orientation, and later indulgence. These dimensions were extended in almost all countries of the world, namely more than 100 countries, in a World Values Survey. The power distance index is defined as the extent to which the less powerful members of organizations and institutions, like the family, accept and expect that power is distributed unequally. In this dimension, inequality and power is perceived from the followers or the lower strata. A higher degree of the index indicates that the hierarchy is clearly established and executed in society without doubt or reason. A lower degree of the index signifies that people question authority and attempt to distribute power. Power distance shows high scores in Latin American or Asian countries, such as China or African areas. On the other hand, Germanic countries, including Anglophone countries, have a lower power distance. For example, in the United States, there's only a 40 score compared to a very high score of 80 in China. In France and Germany, the score also is lower, 68 in France and very low in Germany with 35. This means that in countries like China, hierarchy is clearly established and executed without doubt or reason. On the other hand, in France or Germany with lower degree of power distance, people question authority and attempt to distribute power more equally. Individualism versus collectivism. This index explores the degree to which people in a society are integrated into groups. Individualistic societies have loose ties that often only relate an individual to his or her immediate family. They emphasize the I versus the we. Its counterpart, collectivism, describes a society in which tightly integrated relationships tie extended families and other into in-groups. These in-groups are raised without undoubted loyalty and support each other when conflict arises with another in-group. As you can see here, China scores very low on individualism. So this means that the society is very collective, so based on enhanced in-groups and societies. Various Western countries like France or Germany score very high on individualism, showing that the relationships are more related to strong ties with the family, to the close family, and not to extended in-groups. Uncertainty avoidance is defined as a society's tolerance for ambiguity, in which people embrace or avoid an event of something unexpected, unknown, or away from the status quo. Societies that score a high degree in this index opt for stiff codes of behaviors, guidelines, laws, and generally rely on absolute truth, or the belief that one lone truth dictates everything and people know what it is. This is a lower degree in this index shows more acceptance of differing thoughts or ideas. Societies tend to impose fewer regulations, ambiguity is more accustomed to, and the environment is more free-flowing. Masculinity versus femininity. In this dimension, masculinity is defined as a preference in society for achievement, heroism, assertiveness, and material rewards for success. Its counterpart represents a preferences for cooperation, modesty, caring for the weak, and quality of life. Women in the respective societies tend to display different values. In feminine societies, they share modest and caring views equally with men. In more masculine societies, women are somewhat assertive and competitive, but notably less than men. In other words, they still recognize a gap between male and female values. This dimension is frequently viewed as taboo in highly masculine societies. So we can see that in Asian countries, including China, masculinity scores very high, whereas in countries such as France, masculinity goes much lower. Western countries such as France and Germany have high scores on uncertainty avoidance, which means that these countries do not like risk takings and are risk aversive. On the other hand, Asian countries such as China, for example, score very low, which shows that they are more open in risk taking and less risk aversive. Long-term orientation versus short-term orientation. This dimension associates the connection of the past with the current and future actions and challenges. A lower degree of this index, short-term, indicates that traditions are honored and kept, while steadfastness is valued. Societies with a high degree in this index, that is long-term orientation, view adaptation and circumstantial, pragmatic problem solving as a necessity. A poor country that is short-term oriented uses usually little and no economic development, while long-term oriented countries continue to develop to a level of prosperity. For example, China has a high level, scores high on long-term orientation. Western countries like Germany and France too, so they're all long-term oriented. And finally, indulgence versus restraint dimension. This dimension refers to the degree of freedom that societal norms give to the citizens in fulfilling their human desires. Indulgence is defined as a society that allows relatively free gratification of basic and natural human desires related to enjoying life and having fun. Its counterpart is defined as a society that controls gratification of needs and regulates it by means of strict social norms. China has low scores on indulgency, which means that the society controls gratification of needs and regulates it by strong, strict social norms. On the other hand, in Western countries such as France and Germany, they score high or higher on indulgency, so they allow relatively free gratification of basic and natural human desires related to enjoying life and having fun. The Hofstede cultural model was tested in a lot of international countries, and it has a lot of international applications, domain of international negotiation, in order to better understand other countries' communication styles, expectations, but it's also used in analyzing international management, cross-cultural leadership, and above all, international marketing, where it is very useful in the domain of global branding, advertising strategies, and consumer behavior research in order to better understand the cultures and how to adapt products and services to local habits and local preferences. To come back to our conceptual model, we use the dimension uncertainty avoidance, and we suppose that in cultures which have low uncertainty avoidance, cultures like in China, variables such as privacy concerns and perceived technology fear should have less impact on trust and on intention to use. Whereas in countries like Germany or France, where we have high uncertainty avoidance people, so people don't like risks and want to highly avoid risks, these variables should even amplify, have a higher impact on behavior intention to use than in Eastern countries such as China, which have lower uncertainty and avoidance. So here are the results. You can see here the 3 countries. And so let's have a look on the main results. And so in line with literature, we find actually that for all of the countries, effort expectancy has an important impact on performance expectancy. The strongest link is in China. So you can see the more the smartphone is easy to use, the more it will be useful for the other countries. This is the same. So performance expectancy has a positive and significant impact in all countries. So we confirm the links from the literature. We see that well-being has a highly significant and highly positive impact on behavioral intention to use. So in line also with our hypothesis. Subjective bad being has a negative impact only in France. And so in France, the higher the bad being created through the smartphone, the lower will be the behavioral intention to use. It is not significant in Germany and China. So you can see that performance expectancy impacts positively well-being. So the benefits of the smartphone home and that it increases our performance increases well-being. And as we have seen, well-being increases behavioral intention to use. So it's very important to increase well-being, so which is a highly relevant variable in our model. You can also see that trust is highly relevant and positive and significant by impacting subjective well-being. So trust is also a very important variable. And what you can see is that privacy concerns, there is an interesting link. Link is not significant in China, and neither in France, but it is highly significant in Germany. And it has a high negative impact, which is explainable that German population is very sensitive to all these data leaks and data concerns, data problems, much more than in France. And you can see in France also the impact is negative, even if not significant, but we can consider that it might be also related to our sample. So we can say that in Western civilization with higher uncertainty avoidance, privacy concerns have a negative impact on trust, whereas there's no impact at all in Eastern civilization, China, where uncertainty avoidance is much lower than in Western civilizations, and where people are much more open and used to privacy intruding measures. You can see also that perceived technology security is important and positive impact on trust in all countries. And we can see here that perceived technology fear is not significant in neither of these countries. Actually, we confirm the literature. We show the importance of well-being. We show the importance of trust on behavioral intention to use. And above all, we show the differentiated impact of uncertainty avoidance in terms of privacy concerns that are highly relevant in Western countries, above all in Germany, compared to Eastern countries. So this is the article about smart homes, which is actually the submission in B journal. The second study is about autonomous cars. Here's our model. So you can see here again, effort expectancy, social recognition, and perceived hedonism, which have positive impact of performance expectancy and well-being. We see again, the privacy concerns and perceived technology security have respectively a negative and positive impact on trust, which subsequently should positively impact behavioral intention to use. It is the same for well-being and performance expectancy, which both should positively impact behavioral intention to use. And you have here the user innovativeness, so which the higher the user innovativeness, the higher should be the links between well-being and performance expectancy on behavioral intention of use. Here are the results. Again, in line with literature, we confirm the links coming from the AUT literature. So effort expectancy has a positive link on performance expectancy, and performance expectancy has a positive link on behavioral intention of use of autonomous cars. The easier it is to use, the more it brings benefits, and the higher will be also the intention to use it. We see also here the highly significant link between well-being and behavioral intention of use, in line with our hypothesis and in line with literature. We see that social recognition is not significant. There do not seem to be valorizations through social recognition, but social recognition increases well-being. So that's an important point. We also see that perceived hedonism increases also performance expectancy, namely the benefits perceived. Perceived hedonism increases well-being, so highly positive and significant. Trust increases well-being, in line with literature. Trust increases behavioral intention to use. And we see also in line, privacy concerns decrease trust, and technology security increases. We confirm, most of all our links are also confirmed and shown in the literature. So this article is actually submitted to Technovation, which is an innovation journal, also category 2. And finally, you will see here the conceptual model of acceptance of chatbots. This article is published in Journal of Service Management Research. So you see here the self-quality dimensions. The service quality is actually evaluated through material element, tangibles. So for example, physical uniforms of service providers or the equipment of service providers. The more attractive, the more the design is nice, the more these tangibles are perceived as positive. So this is established in literature. The tangibles have a positive impact on service quality. The competence is another important factor in the service quality model, which is based on the capacity of the service provider, in this case the chatbot, to bring and to give and adequate information. Reliability we find is that a service provider will be reliable and produce a reliable service. Responsiveness is the speed of answer. Empathy is the personal care and individualization that the service provider brings to the customer. And credibility, what the service provider is doing, is perceived as credible and believable. And so we have hypothesized that these factors should have a positive impact on the traditional variables to the TAM model, namely perceived usefulness. We see that tangibles should have a positive impact also on perceived ease of use. And we have the established link between perceived ease of use on perceived usefulness and subsequently on intention to reuse the chatbot. And we see here actually also empathy and credibility should positively impact trust, which subsequently should impact intention to reuse. And then, as I said, we have tested it with a real chatbot. Here are the results. In line with literature, tangibility influences positively perceived usefulness, but also perceived ease of use. We don't confirm the impact of competence on perceived usefulness, probably because we consider that a chatbot should be competent, simply not conceivable that a chatbot is not competent. We see that the reliability is also highly significant and highly positive. We don't confirm the links between responsiveness and empathy on perceived usefulness and empathy on trust. But we confirm the positive link between credibility and trust, which is highly significant, highly positive. We don't confirm, this time in contrast to literature, the link between perceived ease of use and perceived usefulness, which is the link actually from the basic Davis TAM model. We confirm a link between perceived usefulness on intention to reuse the chatbot, but reject the links between perceived ease of use on intention to reuse and trust on intention to reuse. You can see there's some findings which are in line with literature, others not. Now, the idea of the discussion of the result is to explain why our results are in line or why not. So why, for example, perceived ease of use on perceived usefulness is not significant. There may be different explanations. The first of all might be related to the sample, because it's a convenience sample. It's not a representative sample. And above all, it's a sample with young students, for which probably the question about ease of use is not a topic. It's not important, because younger customers are more used to technologies, and above all chatbots. They are all the time on Messenger, because the Flybot is operated in Messenger from Facebook. So for them, probably the perceived ease of use is not a dimension which is relevant or important. So this could be one explanation. Why trust is not considered as relevant, because it might be also related to the younger customers, which are not really concerned by these privacy issues, or perhaps less aware about these privacy issues. This might explain why we don't find the same examples than we found in literature. Another point is also perceived ease of use. Today, most of technologies are ergonomic and easy to use. The variable which was highly important in the computer context in the 80s do not really play a major role today. So this might be another explanation. Why competence has an impact on benefits, because it's probably also a hygienic motivator. So we consider that at minimum a chatbot should be competent. If not, we would not consider it as a technology tool to search information. That could be another explanation. See, when discussing results, it is important to see it in line with the literature review and to explain why we find, or why you find, differences, or if you're in line with the literature.